Last thing we're going to do in this unit with radical functions, how can we solve equations using them, right? Specifically using the graphs of them. You guys learned question like example 1A last year, how to solve radical equations, or specifically a square root equation. We remember solve that. Remember, when you solve an equation, the whole goal is to get x by itself. But I've got some stuff with x. I've got a +2 and I've got a square root sign. Square both sides, get rid of the square root sign. So the square and the square root cancel each other out. And whatever you do to one side, you do to the other. So the equation is now going to look like x + 2. Nothing changes inside the square root after you get rid of it, equals 9. And therefore x is 7. Remember, with radical equations, or specifically square root equations, have to check for what's called extraneous roots. Extraneous roots means solutions that aren't actually solutions when you check it, okay? Because sometimes when you're solving equations like this and you square, you get an answer that actually doesn't work, okay? Like, for example, if I gave you this, you don't have to write this down, but if I'll do a simple one. X + 1 equals -3. So if you square both sides, you get x + 1 equals +9, x equals 8. But if you were to plug this back in, does the square root of 8 + 1 equal -3? No. So in this case, squaring created a solution that didn't work. So you got to be, that's why you have to check your answers. So to check your answers, plug what you got into the original equation and see if the left side equals the right side. So 7 + 2 is 9, square root is 3. Yep, that works. That means that's a good solution. Okay. We're going to focus on how do we solve these types of equations graphically. We've done this at different points in the past. Do you remember how to solve an equation using a graph? I don't know why, but students always seem to have trouble with this one. Anybody remember what we did? What we need to do is graph both sides of the equation. So we're going to graph, we're going to put a y in front of this left side of the equation, and we're going to graph it. And we're going to put a y in front of this side of the equation, and we're going to graph that one. Well, this is what we've been working on in this unit. How would I graph root x + 2? How would I graph root x? What are my 3 points? Yeah, it's a curve. 0, 0, 1, 1, 4, 2. Except this tells me I got to take all those points and move them 2 to the left. So instead of 0, 0, I got to start at -2, 0. Instead of 1, 1, I got to start at -1, 1. Instead of 4, 2, I go 2, 2. And I've got that. Okay. Actually, it looks like I'm going to have to be even more precise. I could create another point, and I'll show you why, the reason why I could create another point in a second. Remember, we go 0, 0, 1, 1, 4, 2. I could go 9, 3 as well, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then here. And there's a reason I have to do that. I'll show you in a second. How do I graph the line y equals 3? It's a horizontal line where every y coordinate is 3. It's going to look like this. These two lines intersect at a point, right? What point do they intersect at? What?
7, 3.
7, 3. Or in other words, the x coordinate is 7, which will always be the case if we solve it algebraically. Okay, so this is our solution. So how do you solve by graphing? Graph each side of the equation, find where they intersect. It's the x coordinates because we're solving for x. So I wanted to do an example before I filled this in up here. So we can solve them graphically by graphing each side of the equation. Just toss a y in front of each side of the equation. Find the x coordinate or coordinates, because there might be more than one, of the point or points, if there's more than one, where they intersect, where they meet each other. These will be the solutions. And that works with any equation. Doesn't matter if it's a square root equation, doesn't matter if it's got an x squared, an x cubed, no, or just an x in it. You can solve any algebraic equation using a graph. Graph each side, see where they intersect, read the x value. And that's your answer. Let's look at a couple more examples. So we've got root x plus 3 minus 3 equals x. How do we solve this using algebra? Got to move the 3 over. Oh, we can't square both sides until the square root is by itself. So I have to do this. Move the 3 over, make it plus 3. Now I'm ready to square both sides. Square and square root cancel each other out. Remember, we don't square each term. We got to square the whole thing. And x plus 3 all squared means the same as x plus 3 times x plus 3. So therefore, well, I only have x plus 3 here. What do I get when I multiply these two binomials by each other, knowing I have to do 4 multiplications? If you multiply and simplify it, It's all going to work out to x squared plus 6x plus 9. Because you get x squared plus 3x plus 3x plus 9. 3x and 3x is 6x. What kind of equation did I end up with? Which means we usually solve these bad boys by factoring, right? But before I can factor, I got to get everything to one side. So I got to get the x over to this side. I've got to get the 3 over to this side. The x is going to join the 6x by subtraction. The 3 is going to join the 9 by subtraction. So I will be left with nothing on this side. X squared. I've got a 6x, and I subtract x when I bring it over. So I'm left with 5x. And I've got a 9 already here, and I bring the 3 over by subtracting, so I get a plus 6. What is this in factored form? X plus 2, x plus 3. And now how do we finish solving it? We set each factor equal to 0 to find what x is in each set of parentheses. So what value of x makes this 0? -2. What value of x makes this 0? -3. Those are our potential solutions. I don't know if they're the actual solutions until I check back in the original. So I'm going to take -2 and plug it back in. Does -2 plus 3 and then the square root minus 3 equal -2? Well, -2 plus 3. -2 plus 3. Square root 1. Minus 3. -2. So it does equal. That one's good. Now we're going to check the other one. When I plug -3 in for x, does the square root of -3 plus 3 subtract 3 equal -3? Well, this is 0. Square root of 0 is 0. 0 minus 3 is -3. So the left does equal the right. These are both good solutions. Okay. How do I solve it graphically? Graph each side of the equation. You don't have to move anything. Keep the left side as it is. Keep the right side as it is. So graph each side, see where they intersect. Because I already solved it, they should intersect when x is these two values. This is going to be a sideways half parabola. I normally start at 0, 0, but this tells me to start where? Back 3 and down 3. So I start there. 1, 1, left 3, down 3. 4, 2, left 3, down 3. There's the left side of the equation. How about the right side? What's y equal x going to look like? Diagonal line. Because if I do a table of values, I get 0, 0, 1, 1, 2, 2, 3, 3. So it's going to look like this. Where the x values where it intersects, here and here. What's the x value at this point? This point? Whoa, that's crazy. Those are the solutions. Like I said, it will always work no matter what the equation. One more example, and this actually I already talked a little bit about on the first page. One more. What's the first thing I do in solving this? Move the 4 over to the other side to get the square root by itself. When I do that, 2 minus 4 gives me -2. Now I'm ready to square. Square and square root cancel each other out, and I'm left with x minus 3. And -2 all squared, 4. Add 3, x should be 7. But if I check it, square root of 7 minus 3 plus 4, does that equal 2? Well, this gives me 4. Square root of 4 is 2. 2 plus 4 is 6, which does not equal 2. Which means 7 is not a solution, which means there is none. No solution. So if I asked you to solve it by graphing, where would you expect them to intersect? Nowhere. They shouldn't, because there is no solution. And we'll see that works. So I'm going to graph y equals root x minus 3 plus 4. I'm going to graph the right side, y equals 2. And it keeps doing it. Very sensitive. Okay, so this is going to move. The points are going to move. Instead of 0, 0, they're going to move to the right 3 and up 4. So my starting point's there. 1, 1 is going to move up 3, or sorry, right 3 and up 4, and end up there. And 4, 2 is going to move right 3 and up 4, and end up there. Y equals 2 is a vertical line where every y coordinate is 2. We can see they don't intersect at all. They never will. Okay. So no intersection, no solution. Okay. We're going to be doing some more of these solving graphically later on in the year as we talk about new types of functions. So you've got to remember, whenever you're asked to solve by graphing, graph each side, find where they intersect, read the x values. Okay. No, I don't want that. What am I doing?